Okay, so let's talk about graphing quadratics with transformation. So the first thing is I need you to think about the transformations a little differently. I need you to think about what happens to the x and y values. So you'll see if we have just regular y equals x squared, if I add 3 to the outside, the way we discuss this is it translates the graph x squared up 3. But how I need you to think about it is that it adds 3 to all the y values. All right, so if it translates it up 3, it's because it adds 3 to all the y values. If I subtract on the outside, we talked about it translates down 1, but I need you to think about it as it subtracts 1 from all the y values. That's why it moves down. All right, so I need you to think about it in terms of the red, not the blue. No, on both, of course. When we transform and graph, it needs to be the red idea. So if I add 3 to the inside, so I change the input. So remember, this goes left 3. It's always inverse what I think when I'm talking about changing the inputs. So if I go left, I'm really subtracting 3 from all the x values. All right, so we added 3 on the inside. Now we're subtracting. You can really see that inverse now. All right, so we subtract 3. If I subtract on the inside, then I'm going to move right, which means I'm going to add 1 to all the x values. All right, again, you can really see the inverse. If I multiply 3 on the outside, what I'm really doing is stretching vertically. Well, I'm stretching vertically, but what I'm really doing is multiplying all the y values by 3. All right, and if I do a number on the outside that's less than 1, this compresses vertically, but what I'm really doing is multiplying all the y values by half. All right, so think of it in terms of how the x and the y values are changing. All right, if I multiply 3 on the inside, and remember to inverse what I think, so this will actually compress horizontally by 1/3, but what am I doing? I'm actually multiplying all the x values by 1/3. All right, and then if I multiply the inside by a number less than 1, and I'm going to stretch horizontally, but what am I really doing? I'm really multiplying all the x values by 2. Okay? All right, and lastly, our negatives. Multiply by a negative on the outside. This reflects over the x-axis, but what's really happening is I'm changing the sign of all the y values. Right? Because I'm multiplying the outside by a negative. So anything that was negative is positive, anything that's positive is negative. I'm changing the sign of all the y values. If I multiply by a negative on the inside, then it reflects over the y-axis, but what's really happening is I'm changing the sign of all the x values. Okay? All right, so we have a nice kind of intuitive part in the blue, but I need you to start thinking about it in terms of the red, how it changes the x and y value. Okay? All right. So now let's talk about graphing. So here's our quadratic function in our special form. This is all the things we can do to it. Right? To graph this, all we really need to do is we'll transform and graph 3 points. We'll transform and graph these 3 points. One's the vertex, and then it's 1 unit left of the vertex and 1 unit right. And you see, if I were to graph this on my normal just parent function y equals x squared, I really only need these 3 points to get this basic parabola shape. Right? The vertex will tell me where I need to start everything. So when I transform the vertex, that'll be my new starting point. And then I'll go 1 point left, 1 point right, and it'll give me the basic shape of my parabola. All right, so this will allow me to do just a rough sketch, and all I have to do is transform these 3 points. All right. Okay, so these 3 points are the key to using transformations and graphing roughly. All right, so let's do this. Let's graph f of x equals x minus 1, the whole thing squared, minus 2. So this is just a transformation of x squared. So here are my transformations. What's happening on the outside? I'm subtracting 2, which means I'm going to subtract 2 from all the y values. And that's how I'm going to transform all the points, subtract 2 from all the y values. The minus 1 on the inside is really adding 1 to all the x values. Remember, insides are inverse what we think. So now, if I want to transform these 3 points, all I have to do is use these transformations. I'll take a point, I'll subtract 2 from the y's and add 1 to the x. So take negative 1, 1. I add 1 to the x value, I subtract 2 from the y values, and this is my new transform point. So negative 1, 1 will move to 0, negative 1. Here's the vertex. I'll add 1 to the x value, subtract 2 from the y value, and here's my new transform vertex. And then lastly, the point to the right, I have 1, 1. I'll add 1 for the x. I'll subtract 2 from all the y's, and this is my new transform point. So these 3 points will be the new transform graph. And you'll see if I graph them, that's exactly what I get. I get a x squared that has transformed translated right 1 down 2. And all I had to do to graph it was to transform these 3 points. All right, so you can see how interpreting the transformations in terms of what happens to x and y is very helpful. All right, so stop the classwork and you want to work on, I'm sorry, the video, stop this video, and you want to work on classwork problems 1 through 11. Okay, so now let's graph this. So we have 2 times x minus 2. So I'm doing 2 manipulations on the inputs. I'm multiplying and adding, well, in this case, subtracting, but I could do addition or subtraction. So when this happens, the order is very important. All right, so let's talk about our transformations. First thing is I'm subtracting 2 on the inside, which means I'm going to add 2 to all the x values. Right? And I'm also multiplying by 2 on the inside, which means I'm going to multiply all the x values by half. Right? Now, there are a couple ways you can do this and a couple ways you can think about this. I think the easiest is just do it in this order. Do all your addition subtractions first, right? And then do your multiplying. All right? So if you do that, it'll always come out okay. So let's transform these points. I'm going to transform negative 1, 1. Okay, before we get to the x's, notice I don't do anything to the y's. There's no multiplying on the outside. There's no addition subtraction. So the y values all stay the same. I'm not manipulating the y anywhere because none of my transformations affect the y value. So I'll just copy down the y. The x value is, and again, do it in this order. I'm going to add 2 to all the x values first, and then I'm going to divide them all by 2. So if I do that, I'll get a 1/2. Then go next. I'm only transforming the x value. So I'm going to add 2 to all the x values. And I'm going to divide all the x values by 2. And I'm going to do it in that order. And this is my new transform vertex. And then same thing. I'll add 2 to all the x values, divide by 2 after that, and then I'll get my new point to the right. So now these are my 3 points that will give me my basic shape. And if I graph it, you'll see here's the basic shape. Okay, so make a note. It's a huge key concept here. Again, there are different ways to think about this, but I think the easiest is do all your addition and subtraction first, and then do your multiplying. Okay. All right. So that's the end of the video. Actually, the end of the video. So just complete your classwork, 12 through 17.